okay, we should get out on the road and educate people on how to incorporate this into their systems. So this is we'll give you a little bit of more background on this today, and then we'll go through some of the strategies for designing some cover crops. So the soil health principles that I work with are, number one, keeping the living root of a plant in the vegetative stage for as many days possible. It's one of the crucial things that we need to be doing that we're not doing in modern agriculture right now. We need to increase the functional plant group diversity in our rotation, in our mixes. We need to decrease the amount of tillage that we're doing in our soils. We need to decrease our reliance on synthetic inputs. We need to build resilience into our soils. And number five, this is the one where most people have or can have issues with, and that's properly incorporating livestock onto the land. It's not necessary, but it really speeds up the process of how we get soil aggregates, how we can even justify some of these cover crop blends and get that quick economic return out of them. So one of the things that got really turned my head upside down on plant nutrition. Last year, I was at No Till on the Plains, and I got to spend a day and a half with Dr. James White, and he was talking about rhizophagy. And it's the process of how plants will consume microbes in order to get the nutrients that they need. He was suggesting that potentially 85% of the nutrients plants take up, ideally, are taken up through this rhizophagy process. And it really drives home the importance of having these diverse microbial populations on that rhizosheath in that rhizosphere, so that this way we can go in, have that diversity and of microbes, have those nutrients available, and get consumed by the plant. And when a plant is taking up complex molecules instead of just ions, it doesn't have to do very much to get into a state that plant needs to use that to do building blocks. When we start taking up nitrates, it takes up 5 different steps and a lot of energy of that plant to convert that nitrate over to amino acid. So having that plant being able to take up amino acids directly or proteins, it's just an absolute game changer when it comes to the active nutrition of that plant. And so I asked Dr. White about, when was, how come I'm just hearing about it now? Why haven't people been talking about it? And he said, oh, it's been developed in the 1950s, but with new technology, they're able to prove it. And so this is where they're moving ahead with it. And to, just to reiterate how important this is and how powerful it is, I was able to spend 4 days with Diane Haggerty over in Western Australia. And you look at the rhizosheath and on this plant that we dug up, this wheat plant, and the really impressive part of it is this is 95% sand, less than 1% organic matter, and yet you see that rhizosheath on there. It's just incredible. And so their program, they use 0 synthetic fertilizers. Rainfall, they normally get about 8 inches of rain during the growing season, but the last few years they've been down between 3 and 5. And so their whole fertility program is putting compost on their seed. They're getting more into the Johnson Sues, but they are buying and bringing in tested compost. They're doing a compost extract in furrow, and then in season they're going in with a compost extract foliar. 0 fertilizer for 22 years, and if they do use a herbicide, they follow it up with a compost extract foliar application. This is putting all this biology into building up these soils that are 80 million years old with the biology right on the seed, right in the seed furrow. And so that these microbes are able to work with these plants and provide everything that these plants need. And so I was asking, okay, so, as Christine Jones or Chris Nichols says, we really need to get the Y word out of agriculture, and that's the word yield. We have to replace that with profitability. But just because I'm not familiar with the profit scale in Western Australia versus Western Canada, we were talking yield, and they were doing very well. They were performing as well as what their neighbors were. But what we're finding is, because we weren't messing up the soil chemistry with adding external chemistry and just using biology, the the neighbors' soils were pHs were around 4, where the Haggerty's were around 6, right across the fence. It just, once again, the biology will move and manage that soil for themselves to get as close to neutral as they can, as quickly as they can. And so when I saw what they're doing, that's one of the reasons why I to work with a company with like EcoT is a no-brainer, just from the standpoint of that's their business. So it's great to see, once again, when we start talking about science, about when we can start replicating things in different areas, there must be something there. And so if Haggerty's are doing it on 35,000 acres, and I guess the other story I should be telling about this is a year ago they picked up 1,500 acres, new land that was highly tilled and lots of synthetics. And they said for 1,500 acres they weren't going to go and buy fertilizer and do a bunch of sprays on it. So they went in with this compost in the seed, the extract in furrow, and then the foliar application of compost extract. And they end up getting the same yield on this new land that was addicted to these inputs as the rest of their fields. And so this just shows me the power that we can take something that is highly addicted to these inputs, get the biology down, and we can actually convert these into a biological system that functions. So Dr. Elaine Ingham, one of the things that she talks about in her presentations, if you have a plant nutritional deficiency, it's basically because you have a soil microbial deficiency. And where we get that from, to have those microbes to free up those nutrients that we need that diverse microbial community in our soils. We need it active. And how we do that is having the different plants growing, the different functional plant groups. So we have different root exudates. We're bringing in different microbiomes on seeds. With the compost, we're enhancing that microbiome of that soil, and we're making it stronger. We're making things function. And so within this soil, what's up on the slide right now, this is actually from Western Australia. So there's some rotifers, there's some nematodes, and the I guess interesting thing that Dr. Zavala had said was that the species that were there were from the same genus that we have here. So it's the same active, genuses, little different species. But it was really interesting to see that, even though they're other side of the world, our soils are very, very similar. When we start looking at the soil biology, and the real kick in the teeth on this is when I went through university, the two classes that I thought were a waste of time were soil microbiology and plant ecology. And so what am I doing now? Well, those two things. So one of these things, once again, Dr. Elaine Ingham, one of the things that she was talking about is this fungal bacteria ratio. And it's really interesting from the standpoint of when we look at this curve. I've seen other depictions of it, but I find this one's fairly easy to work with from the standpoint of, looking at, so in this case, it's going to be the pounds of fungal versus pounds of bacteria, or kilos, or it doesn't matter. We're just talking about weights in the soil. So as we move along and we start building this fungal bacteria ratio, and so when you have bare soil, it's very, very bacterial. And then when we get that fungal bacteria ratio of 0.1, this is where it says we're growing weeds, we're growing Johnson grass because this is from Texas. High nitrates in the soil, and we have lack of oxygen, which is compaction. As we build our fungal component, we get away from the weeds. We get into different types of plants wanting to grow. Because we have the fungi, we're going to have better soil aggregation, so we don't have this lack of oxygen. We have this soil aggregate. And if anybody has tried growing things like Sicer milk vetch or some native species of grasses, and we seeded them into canola stubble when they're growing, the year after, they don't grow. They don't. You don't see them, and it may take quite a few years before we start seeing them, and that's because those plants don't have the signal to grow. Those those native species need to be up close to that 1-to-1 fungal to bacteria ratio. Saying that, if we had canola stubble and we tried planting evergreen trees in it, most likely most of them are going to die, because if you look at the top of the screen, the fungal to bacteria ratio for conifers is 100-to-1, whereas we're at 0.1. So that plant doesn't have that signal to grow. So as we seed down a pasture or a hayfield, that first year we'd have to have a nurse crop because there's weeds growing. We need to hay them off. So we have every weed that we have under the sun growing because, well, we don't have weed control issues, so we'll just hay it off. Year two, a lot of those early successional weeds or plants disappear, and our perennials take off, and so it keeps going until the point where our production starts dropping off, and then we start seeing rose bush, we start seeing some shrubs starting showing up. So that indicates that our fungal bacterial ratio is now over that 1-to-1. And it isn't the fact that our fungi in the soil is right through the roof. It's because as our plants start to mature, we get less root exudates. And when we have less root exudates, we get less and less bacteria. So we get less nutrient cycling. So our shrubs and vines and bushes are more effective at taking nutrition out of that soil as compared to our grasses. So what we need to do is increase our bacteria to drop our fungal to bacteria ratio to now stimulate more grass growth through more root exudate, through bacterial growth, and managing it that way. So it's really interesting when you look at this dynamic. So when we go in, we have this hay field, and we go in, we disc it, we spray it, we fertilize it. That increases more bacteria and sets back our fungi. So that moves us back. So then, this is where, prior to settlement, when fires would go through, the grass would green up and grow better in native prairies, because when the fire goes through, we have all that residue get released back into the soil, feed the bacteria, so that drops our fungal to bacteria ratio. So we get more bacterial growth, we get more nutrient cycling, and we get more plant growth. Then we get more root exudates. Beautiful system. And so when we see this, we can see how our management will move this forward or backwards on this list. So this ratio determines what plants want to grow. So when we have these pioneering plants, aka weeds, low fungal bacteria ratio, we tend to have high nitrates in our soil, and we have low available calcium. And so it isn't the fact that, in a soil test that shows that we have 8,000 pounds of calcium in the soil. It's not it's not on the colloids that is available to those plants. And so when we have these 2-to-1 swelling clays, when we do our base saturations, we have those 100 spots on there for the different nutrients, and 65 of them are the calcium. Now, when it gets dry, those two colloids come together. Now we've lost that space in between. We don't have access to that calcium in between those two soil colloids. So we need that, get that available. And how do we do it? Once we get that fungal bacteria ratio up over that 0.3, now with more fungi, now we're going to have more hyphae going in between these soil colloids, so that when it dries, now those soil colloids will have a bit of a space in there. They'll have the mycorrhizae in there, and now we can access more and more of this calcium out of the soil. And most researchers hate this fungal bacteria ratio, because if you tested it, and if you have a microbiometer and test, this number will switch very quickly in the soil, because in the bacteria, you can increase your bacteria populations tenfold in 4 days, given the right conditions. So it isn't a snapshot in time. It's looking at the landform, looking at what's growing there, and explaining why these plants are growing or why these plants are not growing. So it's a bit of an observation thing that I work with. So as we increase this fungal bacteria ratio, our soil compaction starts disappearing, our water infiltration really starts improving. Our pioneering plants, our wild oats, cleavers, redwood pigweed, lamb's quarters, green foxtail, they don't get that signal to grow. They don't have that free nitrate to stimulate their germination. So they just magically disappear. And that's where, when we start breaking up that hay field, when, there's no wild oats and hasn't been there for 10 years, once we start overworking it, and once we start over fertilizing it, we start, damaging our fungal populations, and we drop below that 0.3, then wild oats start showing up again. So it's a really, well, like I said, just a fascinating way of looking at succession. As we have this stable soil aggregates, now we can start pushing our root depth down. Our soil nitrates start decreasing, and we start becoming more ammonium as our nitrogen source. And the whole production system, it's a lot more stable. With EcoT that Langham, there's a great report that Braden has done up, and just showing the fact of dropping his, in the trials, having the grower standard, and right beside it was using the biologicals plus adding half the fertilizer, getting over 3 years the same yield, but 50% increase in our aerobic zone in that soil. So it can be done. It has been done, and it's just outside of Saskatoon if you want to go look at it. One of the things that when we're looking at production systems today, we've simplified things, and I say we because humans, like, we're lazy, and so monocultures. The reason why we started growing monocultures is because that's the easy button. But nature loves functional plant diversity, and this is part of the reason why we get these weeds starting to creep in. What we need to have, and once again, I'm not very smart, so I keep it relatively simple. And so I use the base 5 functional plant groups. So your grasses, your legumes, your brassicas, your non-brassica broadleafs, and your forbs. Within each one of those, we have warm and cool season species available. And within each one of those warm and cool season species groups, we have annuals, biennials, and perennials. And so this is where we can gain this functional plant group diversity. So when, in Australia, there's a couple of seed retailers that I got to know, and they said, what do you think of this pasture blend? It's 5 ryegrasses and 2 clovers. Really, really diverse. And I said, no, because that's only 2 functional plant groups. You're dealing with a cool season grass, now is a perennial grass, and they're dealing with a perennial legume. So there's no, only 2 diversity. We need those forbs. We need this diversity. And it's crucial in order to, if we want to get away from the nutrient deficiencies and diseases and all the other issues we have, the more of this diversity we have in a rotation growing together as relay cover crops, this is what solves a lot of these issues that we have. So, weeds, when we start looking at that, weeds, what are they? They're just a plant growing in a spot that we don't want them. And basically they start creeping in because our system is missing some ecological function that these weeds are going to supply. And what we've found is if we replace that weed that's coming in with a plant with similar ecological function, those weeds now disappear. And so in the picture, you can see the 2 roots going down, and the left one is Canadian thistle, and the right one is chicory. It is from the same functional group family. They have very similar roots, but with the chicory, assuming that we have enough calcium in the soil, it will then disappear. And so it's going to be something we can manage a lot easier than we can a thistle plant. If we have wild oats, there's a farm up at Spalding, an organic farm. I suggested putting some Italian ryegrass in with his spring oats. And in the spring, so seed all at the same time. And he said the 2 quarters where he had the Italian ryegrass and the one he didn't, right across the road, where he had the Italian ryegrass, the yield was down about 2 to 3 bushels an acre, but his weed pressure dropped by 80%. And that's just by having that Italian ryegrass in there. And we'll hope if we have enough time, we can get a little deeper into, the in quotes competition effect of the Italian ryegrass with the oats. And one the other, on the bottom there, I have it's not a plant, but if we want to get away from synthetic nitrogen, let's start cranking up the legumes. And there's concern about root diseases, but doing these polycrops, increasing your biology, and using things like lupins in the mix, it really reduces the disease incidence of our legumes. So if we just go out, and it doesn't matter if we're organic or conventional, and we go kill the weeds, guess what? If we haven't changed our management, those weeds are going to keep coming back. And if you don't believe me, then with wild oats, we've been spraying and tilling and killing wild oats for how many years? And we still have wild oats. And nature says, "Oh, okay, you're trying to take away one of my tools. Well, we're going to have herbicide resistance. We're going to have, if you're organic, okay, so now we're going to have more phenotypes that will mature earlier or mature later or germinate later, so that this way, you always till in May. I'm going to germinate in June. So if we ever try outsmarting nature, it isn't going to happen. What we need to do, and it doesn't matter what problem you have, we need to address the cause. It's just like the guy that went to the doctor, and went to the doctor and said, "Doctor, it hurts when I touch my head, and it hurts when I touch my ribs, and it hurts when I touch my knee. What's wrong with me?" Doctor said, "You have a broken finger." And so this is that thing of, okay, yeah, there's pain, but why? What's causing it? And so we have to go back to that base reason of why these issues are there. So for wild oats, when we have excess soil nitrates, boom, we're going to have wild oats. We're going to have red root pigweed. We're going to have lamb's quarters. With the foxtail barley, how do we get rid of that? Well, we need to reduce that salinity. We need to have an increase in our calcium flux. We need to tie up those soil nitrates. And so this picture is of one of my fields during the 2011-2012 fiasco, when we're getting 40 inches of rain. Weren't getting on the land until July. So went in and once again, soil health-wise, not the greatest, but I used tandem disc, disced it all down, went in with the cultivator, leveled it out, and seeded 10 pounds of radishes. So the radishes had a taproot to go down, so it opened up the soil. It brought up a bunch of calcium, so when the radishes rot, gave a burst of calcium into our soils. And because it's a brassica, it's a scavenger, so it tied up the excess nitrate, then turned around and slapped it into the next crop, and managed that salinity. And 6 years later, you can see the line on the 80 acres where we stopped seeding the radishes. So it's really effective once we understand the system. So at the end of the day, we need to understand the ecological advantage of what we're trying to get rid of, and we need to change our management so we take that advantage away from the weed and give it back to the crop that we're trying to grow. It's so ironic that these weeds are so healthy and they're so hard to kill, and yet our crops we're trying to grow are wanting to die. They're not healthy. So it tells me that what are we managing for? We're managing for weeds. We're managing for disease. And this is where we have to change our management. And one of the things is this addiction to tillage, and seeing a lot of it. And when I was down in no-till in the plains, the one guy was talking, zero-till corn, and he said, yeah, they run the speed disc in front, and then they run the corn planter through. And I said, how is that zero-till? Well, they have a zero-till planter, so that makes it zero-till. Okay, but basically, when we start looking at excessive tillage, once again, surgical tillage, absolutely. Prescriptive tillage, perfect. To go out and just work because that's what we do doesn't make any sense to me. So it's like a tornado going through a trailer park. The positive is if we do it, with purpose, it's going to remove some of the things that we want to get rid of, but it's going to set us up so we can rebuild it better. And that's one of the things that we want to do. When we go in with these speed discs and make the powder on top, and we see that dust coming out behind it, that's destroying our soil aggregates. It's damaging our fungi. And when it damages the fungi, and that fungal bacteria ratio drops, then that soil is going to slake more. So working the soil to allow more water infiltration is a fallacy. We build soil aggregation, we get water infiltration. And that's once again going through 2010 to 14 with 40 inches of rain each year. In 2015, when we were getting a rain through, there was no water sitting on our land, and across the road there were sloughs all over the place. And well, maybe we were going out at night and pumping our sloughs over to the neighbors, maybe, but maybe we had it going into the ground, storing it where we need it. When we do that tillage, it's not only damaging our fungi, we're promoting more bacteria growth in our soils. Once again, dropping that fungal bacteria ratio. When you have that active bacteria in the soil, and we don't have plants using the nutrients getting freed up, especially the nitrogen, then it starts producing more nitrate. When you get that nitrate, because nature says, oh, you guys need a little help, we're going to grow some of these weeds to help tie up that nitrate so don't lose it. And that's the whole, once again, that fallacy, the organic wise, the whole idea of going out and doing early spring tillage to get weeds growing, that once you understand this system, it's not necessary. We need to have that growth on the surface, old growth, both the tight seed end ratio and wide seed end ratio, narrow openers. We can absolutely be zero till on organic acres in Western Canada on I would say 3 out of 4 years, 4 out of 5 years, and I'm working with a guy at Moose Jaw that he's doing that. His goal is to work the land once every 5 years, so it can be done. Bricks. This is one thing that as agrologists, one of the tools, really easy tools we need to have out in the field. Nice and simple. Basically, when you need a garlic press, you need this bricks meter, and so this is the manual one. It tells you a little bit more than the automatic one. I'll have a picture of that right away. But it's just the measure of dissolved solids in the liquid sap. So they use it in wineries, in alcohol production, in food production, just checking to see where the dissolved solids are. In particular, the biggest thing we're looking for is those sugars, proteins, oils in that sap. And one of the things our daughter did in grade 7 science in junior high is she did a bricks test of conventional and organic fruits and vegetables. So just went to local grocery store and grabbed organic and conventional. And then we did a blind taste test. And guess what? Between the two fruits and vegetables, every time, or she picked on the blind taste test, the highest bricks every time. It reflects that taste and palatability. And, we've all had that strawberry that was nice and red and looked nice and juicy, and you bite it and it has no taste. And then you grab the next one and it's right full of taste, and it just, punches right in the tongue, just beautiful taste. So that's part of what we can see. And it reflects that photosynthetic activity in that plant. So when we have high bricks, we know that things are happening in that soil. And so this refractometer, it's you can buy a cheap one, it's about $35. You can get glass prisms, which are a little bit better. They're a little more money, but we can learn a lot from it. So one of the things we can do is go out in the evening, check the bricks in a certain area, come back in the morning and check. And if the bricks levels are the same, that means we have a boron problem. When we're looking through it and you see that nice sharp line at 15, that indicates that we have a calcium problem. Our calcium levels in that plant. So we want to have that fuzzy line of, it's somewhere between 10 and 20. So we're going to guess it's about 15, so that you can see when we have a bricks below 8, then we have problems with disease. Once we get above 10, our weeds start disappearing, and we get a bricks of 14, then farming is fun. And so here is a heart colony out at Bigger. We went in with a multi-species cover crop that they were going to silage. There was some dairy manure, 6,000 gallons of dairy manure went down. And then he went in with some yucca and some milkway foliar. So one of the things that one of the issues that they had was they were having some problems with kochia, and they needed better feed. So that when we went out and we had this multi-species crop, we didn't put any fertilizer down. They did do a pre-seed burn-off, but no herbicides or fungicides in crop. Put on the milkway and the yucca. This is the Brix of the crop, 21. So we went from Brix last year probably around 4 or 5, and in 1 year we got the Brix up to 21. So all of this is all attainable, and when you have numbers like this, and a grazing animal can detect a 0.1 change in Brix, and so this is where when we're going through, and we're stock rate grazing, that's why you'll see some things, some species disappear in the species of plants. And number one, anything that flowers will have high Brix. And so if it is a flowering plant, one of the things that Dr. Christine Jones talks about is she rates the paddocks, the pasture paddocks, by the number of wildflowers out there. The higher the number of flowers, the better that paddock is being managed, and the more productive that those species will be. So that going back to the stock rate grazing, so that if that animal is not regulated, they'll go back and they will keep biting the plants with the highest Brix. They will avoid the plants with the low Brix. So things like tall wheatgrass will have inherently low Brix. As that plant starts mature, the Brix drop off. The reason why they may graze it is for other reasons. But when we're talking about green plants, they'll always selectively graze these high Brix. So having this amp grazing where we're high density, moving them quickly, that's going to do less damage to these good grasses, and we'll keep those good grasses in our blends for a longer period of time. So I jumped ahead of myself. So young plants have higher Brix. So this is where we want to have, these animals want to be grazing it. So if we go back and we get that second bite, that the roots are going to start they're going to slough off. And so the more bites we have and the less top growth we have, the shallower and shallower that root system is going to be. And that's going to reduce our drought tolerance. It's going to reduce how quickly those plants will regrow. And so this is where that orchard grass will inherently always have higher Brix than brome if it's at the same stage. And this is meadow brome or smooth brome or hybrid, doesn't matter. Orchard grass is a sweet grass. So animals will preferentially graze orchard grass over just about anything else. As we start overgrazing it, producers complain that, well, no, I had orchard grass, but it didn't last. It didn't hang around. And then, in my brain, I just, okay, so the grazing management isn't there. We need to, that's one of the things we need to do is improve grazing management, and returns can be that much better. And so that when we start talking about Brix, modern agronomy, it's all designed to lower the Brix of these plants. So your fertilizers will always lower your Brix. Once again, because grazing animals are great testing units, if you fertilize one strip of pasture and then watch how animals graze it, the growth where you put the fertilizer will be higher, but the Brix is going to be significantly lower, and the animals will graze where you put that fertilizer last because of the Brix. When we put on a herbicide, when we put on a fungicide, when we put on insecticide, that's going to lower our Brix. When we do tillage, that's going to lower our Brix. And that low Brix is going to bring in disease and insects. Haggerty's, if they go out and they do a herbicide application, they do not use any fungicide. Christine Jones, once again, says, in regen ag, the first thing you do is get rid of fungicides. We're not looking at killing things. We want to build things. We want to grow things. So when Haggerty's go out and do their herbicide application, the next day they go in with a foliar compost extract. And what they'll see is a rebound of about 5 points. So putting on the herbicide, it'll drop about 2 to 3 points. You put on the compost tea, boom, it jumps back up 5, and it gives an indication that the plant's recovered. So when we want to build Brix, adding this compost, it's one of the easy ways. add that, get that biology in our soil activated. We need that plant diversity. We need to have those root exudates for as many days as we can, and we need to keep that soil armor on so we keep that soil cool, keep the moisture where we need it, we can use it, and make that function. So cover cropping, it's a little kind of roundabout way of getting there, but we're getting there. So using these cover crops help address all of these issues, and it actually enables us to manage the cause of these issues, not just the symptoms. If we understand where what the causes are, that living root feeds the soil biology, and that is key when we're dealing with any of this. Gabe Brown talks about the fact that waking up in the morning, he used to think about what am I killing today. Here is what am I going to see new today? What new life are we going to see? This soil biology will regulate nutrient cycles from biofeedback relationship with the plants. Once again, they're way smarter than us. They know what they need. They know when they need it. Because as we go through every micron of these root hairs, the pH will swing from a 2 to 11. Why? Because the plant knows if I have this condition, I'm bringing these microbes in, and because this is what I need. And so when we start throwing these synthetic inputs into the system, when we do over tillage, when we have monocultures, that just interferes with this plant microbe relationship. And this is the reason why we're having so many issues in agriculture. We've lost the diversity. So when we're designing the blends, number one that we have to do is set goals. And it isn't the goals of a soil test of I want a 60 bushel canola crop. It's I want to increase water infiltration. I have this weed that I want to get under control. I'm worried about erosion. I have nutrient cycling issues. That's the goals we're looking for. We want to observe the weeds that are out in the fields. That's going to really help with what species we use in our blends. We want to determine what species composition do we want. So once again, going back to our functional 5 groups, how much of each do we want? And that's going to be influenced by the seeding date and what our soil moisture is. And then we want to calculate what kind of seeding rate density do we need. So here's a couple of blends that I'm using for this. In this case, this is a grain producer. And so he's going to use it under all of his cereals. And so it is half a pound of Italian ryegrass and a pound of subterranean clover. So both of those are going to grow, 3 to 4 inches tall, stay nice and low. They're not going to produce seed in year one. The Italian ryegrass winter kills. We're adding, 4 seeds per square foot. And we'll have, this guy's in northern Alberta, so he's going to have 35 seeds of wheat in with it. And that's the blend. So it's about $10 an acre, and that's going to be tying up excess nitrate. That Italian ryegrass will re-release it as complex nitrogen, so that'll help suppress weeds. That subterranean clover is going to be fixing nitrogen, building mycorrhizae. The Italian ryegrass will build mycorrhizae too. Nice, cheap little system to get that living root in the soil. Check off those boxes that we want. For a livestock producer, I put together this blend where they're going to use some of their oats and peas. And with it, they're going to put some crown millet, some Japanese millet, Persian clover, crimson clover, plantain, chicory, Italian ryegrass, sunflower, phacelia, and teff grass. And once again, you look at the numbers, and okay, so this is going to be $34 an acre. Use your own stuff. You're building soil. You're building soil. This type of blend, it's kind of like the one we're using up in Prince Albert at a dairy where he's not supplementing with much grain. He's able to feed right out of the silage bag into the bunks without having starch in the diet, and it's changing the animal health for them. And so one of the things that Paul has been working on is this cover crop simulator, so that we can put in a blend into that spreadsheet, and it will give us a view, a potential of what this blend is going to look like. So not only above ground, but also below ground. So that when we put in that little bit of sweet clover, or we take that out, you can see that we lose some height on the top end. But when you flip that, it's a 360 model, so you can flip it upside down and see what the roots are doing. So that if we had canola or barley or annuals, you can see that the roots are conjugated in the top 6 inches. You put in a little bit of chicory, you put a little bit of sweet clover in, all of a sudden we're going down 4 feet. and what that does to infiltration, what it does to soil biology for carbon sequestration, all of these things, it just makes a huge difference. So that's one of the things that we're working on for 2026. So the keys: avoid competition. So that's using the wrong maturity, using warm season species too early in the season when it's too cold, wrong seeding rates, so we get the too much, too dense, overuse of these scavenger plants, avoid allelopathy, build synergies, build that soil fungal populations, the mycorrhizae fungi friendly blends. And this is Jay Fuhr in at the Medican Farms. They seeded alfalfa into their corn. Best corn crop on the farm. If you have overwintering cover crops, monitor that spring moisture. If it's dry, terminate it early, leaving that armor on the surface. If it's wet, allow it to grow, allow it to dry out that soil to so you can seed and not create more compaction. If you're scared of weeds, terminate the cover crops at flowering. Pick later maturing species. Pick biennials at winter kill. Those are the easy buttons. So in order to create change in the microbiome, we have to do these major changes. That's the reason why our soils are addicted to these inputs. We need to change and improve and build our soil microbiome in our soils. So can it be done? I've worked with a lot of producers in across Canada now, into the States and Australia. So it's neat to see that it's all the same problems. It's just local agronomy that we need to work on to solve these issues that we have. So thank you for your attention, and we'll open up for discussion.
You bet. Thank you very much. So we can start this off with for some of your compost, do those file under an organic format?
So that's the whole thing. When we start looking at the organic, like when it comes to the organic protocol, as long as organic products are used, then it's eligible for organic production. EcoT, they do use the organically approved inputs, so they are. Biggest thing is when we start playing around with the organic, well, anytime we're doing any compost, make sure that if you're using straw, there's no glyphosate on it. There's not pre-harvest glyphosate. There's very minimal, hopefully zero fungicides, because that gets carried into the compost. So, if you put junk into it, you're going to get junk out. If you manage it, you don't manage it properly, you're going to get junk out. And so, those are the things that, once again, compost wise, it's scary, especially when you get into it, because the only thing worse than bad compost is bad compost. You can't do anything with it.
Yeah. Of course, there's going to be a kochia question. Are there any recommendations for weed competitors against kochia? I met a farmer once that grew cover crops with beet in southern Alberta and didn't have any kochia problems on his field. Sorry.
So with kochia, once again, a great book that I highly recommend is When Weeds Talk by J.L. McCammon. J.L. McCammon, When Weeds Talk. Great book, because it has a nice little chart in the back that gives the ecological advantage of each of these plants that we call weeds. So with kochia, high sodium, high nitrate, and low calcium. So what we want to do is increase that calcium availability. We want to tie up that nitrate in the soil, and we want to tie up either the salinity, whether it's a sodium or a magnesium salt. And this is where we need those taproots going down. We need to have that armor on the soil surface, and where possible, try and get some more calcium put into the system. And so the question I always ask producers is, where's calcium located in the plant? And of course, it's in the root, it's in here, it's in the cell walls. So the more cell walls we put back into the soil, especially into the ground, that's what will help. So having sugar beets growing in areas that are where it's relatively warm and we have the moisture. They're not great for drought tolerance. But if you have irrigation, grow some sugar beets on there. The sugar beets are able to take up that salinity, take it into the cell walls, and create a vacuole and store that salinity inside that cell wall to help drop that salinity around that plant. Because it produces a great big tuber, it's going to bring up a lot of calcium. It has a taproot, so it's going to open up that soil. It is a scavenger, so it's going to be soaking up all that free nitrate. Okay, so now we can get moving ahead. Do we want to do a monoculture of that? Not in my world, but put down some sweet clover, put down some winter triticale, winter wheat. Get that green vegetative plant growing, so we get the mycorrhizae going, we get the good ground cover. We're using the water down below the soil surface, because where we get salinity is where we're evaporating water. So the water moves up, evaporates, and now we have the salts. And so the deeper we have these tap roots, and that's what's great about that simulator that we're going to be coming out with, that's going to really give us a good indication of, do we have enough roots down deep? What's that density per square meter? And those are some of the things. The other thing we can be doing that I really like is using alfalfa pellets. Alfalfa pellets are made from plant tissue. There's going to be a fair amount of calcium in them, and they're all bound with carbon. So now that system can use it. Putting down lime and stuff like that, it messes up our Mulder cycle. There's a lot of negative interactions that I don't like about using elemental products.
So Paul says, I appreciate the presentation, very informative. Do you consider nutrient balance equations in your work? So consider nutrients being removed from crop harvest. And is it realistic to remove all synthetic fertilizer, really? Yes, a healthy soil, applying what you're promoting will help farmers get there, but you have to replace what you're taking out of the soil as well. Yes, you can replenish soil nitrogen with pulses. However, PKS, etc., need to be physically added to the soil. Manure doesn't work, and for other nutrients. However, that is just adding nutrients again that have been removed from other soils. So is removing all synthetic crop nutrients realistic?
Absolutely. Did it for 15 years on our farm, and when I did soil tests, everything was cruising right along. I did have animal impact. Manure does work extremely well for replenishing nutrients. To go out and compost it and put it on, not so much. The biggest thing with like this whole mining thing, it drives me crazy. Dr. Dwayne Beck from Dakota Lakes Research down in South Dakota, I asked him if he did a mineralogical test on his soil, which, this is, if you're worried about mining, do that. That's a number we need to see. So I asked him what his phosphate levels were in his test. So he went down 4 feet and he had 6,000 pounds of phosphate fertilizer available there in the soil. So if you do, assuming it's linear, that we're going to have 1,500 pounds of phosphate in the top foot. We're going to be 750 pounds in the top 6 inches. And when you think of what phosphate fertilizer, the efficiency of it, it's maybe 15% effective. And so to put 15% down, I did the quick numbers on it. If you're putting down 30 pounds of phosphate, you're 15 pounds of effective. So you're getting 4.5 pounds of phosphate that the plant has available. If you use alfalfa pellets and put 200 pounds down, you're going to be at 3 pounds of available phosphate. And so when we put the organic, the small organic, not the big organic, nutrients down, stuff that's attached to a carbon molecule, way more efficient. We are carbon-based molecules. All of the food, all of our nutrition we get needs to have a carbon bond attached to it for most of the stuff we're eating. So the biggest problem we have is we are dealing with monocrops with crop roots that are going down 3 to 4 inches. Yes, we're mining that soil. When we put in some chicory, when we have a forage in rotation, when we have these tap roots going down, we're increasing the volume of soil that we're using. And so by definition, in the Yorkton area, with the oxbow loam, I should have about 4 inches of topsoil. After 20 years of doing what I was doing, I had over 26 inches of A horizon. And so if I was farming and farming relying on 3 inches of topsoil, yes, I would be mining the soil because I'm not utilizing it. Going down 26 inches, I've got I've increased my nutrient pool. And so this whole thing of mining, yes, it is a problem. Elaine Ingham says that we have enough phosphate in our soil for the next 1,500 years if we didn't apply any. You listen to Christine Jones, the phosphate paradox. Great YouTube thing to listen to. It just the reason why we have these problems is because we don't have the biology. We don't have active biology in the soil. We don't have the diverse plants. We're not getting the livestock impact. The manure, I have guys that I have told no more manure on your land because your phosphate levels are just through the roof. So it's going back to management and putting on 30 pounds of manure on a piece of ground, it's irresponsible. But properly targeted, it's a great tool to be using.
Wow. Oh yeah. 5,000-acre farm implement these practices? So did they start on a few acres and work at it gradually over time? Or was it an all-in process? And do you have suggestions for large farmers here starting to implement these types of practices?
Well, that's what I was really interested in seeing what Haggerty's are doing, because if Haggerty's are doing it on 35,000 acres, and in total they have 5 employees, they can do 35,000 acres, a little different set of rules over there. But, when you look at it, 35,000 acres, okay, they can do it. So why can't we do it here? So, the number one, get a mentor. Find out someone that is doing it. There's some great people out there doing some fantastic things, and there's some WhatsApp groups that I belong to. There's 500-600 people that are in these groups, and as we go along, you'd be shocked at how many people in your backyard are doing it. So are they using the compost? Like on our farm, I wasn't composting. I wasn't to that point. I was all doing it with the Eco-Tea and with cover crops, crop rotation. Then I started bringing more livestock in. So find out a system works. And so that one blend that I did with the Italian ryegrass, depending on where you are, Italian ryegrass, once you get south of number one, it's a little riskier because a little dry, small seed. But I'm working with a couple guys down, in the McCord area that with their durum, we put in 15 pounds of winter triticale. That winter triticale replaced the Italian ryegrass, but they put it in with their durum. Their durum was waist high last year or 2 years ago, sorry. No weeds, very little fertilizer used. And right across the road, the durum was under knee high. And because, once again, they're using best management practices, under knee high. And it's right across the road. And so one of the neighbors said, well, that's easy to explain. The rain stopped right at the road. But in reality, what that winter triticale does under dry is still ties up the nitrate, re-releases back into the system for the durum to use, but it creates the micro water cycles. So those little vegetative leaves, they cool down quicker than the air. So then you get water droplets on it. So now that winter triticale can absorb it, or they'll roll off, land on the soil, and feed the durum. If the winter triticale absorbs it, it has now more water in it to release more root exudate to feed the biology to then feed the durum crop. So it's a win-win. So there are some really easy tricks to do. It's just finding a system that is working for you. So if you are interested in going through options, my contact information's on there, or go to covercrops.ca is my website. Look me up on Facebook. If it was fairy dust and pipe dreams, I wouldn't be on the road for the last 15 years talking about it. And, I'd soon be hiding somewhere selling up some other snake oil. It's real. And it's, figuring out where your bottlenecks are and management and what your goals are. So onwards, upwards.
Okay. When we talk canola, does that not suppress cover crops?
So when we go in with canola, and we start looking at what our options are. If we go with clearfield canola, we can put in some annual clovers with it to create a cover crop. Otherwise, what we're doing is going in with canola, doing our herbicide, and then hopefully broadcasting a cover crop into it. Sometimes it doesn't work. Most of the time, it doesn't work. It's a nutrient scavenger. It's highly competitive. It's a kind of a sucky plant, so we have to keep pour the nutrients to it. So the biology is lazy. For our farm, I got rid of it, and I once again have a couple budgets comparing a wheat canola rotation to an actual 4-year rotation, where I was using a cover crop in year 3 with no income. I was just growing it and letting it rot for feeding my soil. And when I went through the budget, I gave it to my peers. I said, look at the numbers. How close are they? And once again, this isn't $20 canola years. This is what I call average years. And they said, okay, they're happy with my budget numbers. But when we go through it after those 4 years, so canola wheat, they had very similar gross dollars, but where we had the cover crop, once again, with zero income, our inputs that we needed were a third. And that, when we start looking at, once again, this yield word, get rid of it. We have to look at the net dollars. What does that crop do to our net dollars in our system? And that is really important. So if we can, grow a cover crop and fix enough nitrogen, that's this cover crop behind me. My goal was to grow this cover crop underseeded to perennial ryegrass, so I grow perennial ryegrass for seed without buying any nitrogen. It worked. So I got no income this year out of it, but that income, if I would have grown canola or wheat as my nurse crop for the perennial ryegrass, anything I would have made would have turned around and put back into buying fertilizer. And if you look at every square meter of our field, we have 440 metric tons of nitrogen over top of it. And being from Yorkton, I'm Scottish and Ukrainian, I'm cheap. If I can get something for free, I'm taking it. We need the biology. If we get the biology in place, we can function, we can cycle nutrients, all of this stuff. And once again, if you're concerned about mining the soil, start throwing some of these forage seed crops in. So instead of taking a 60 bushel canola crop off, we're taking off 300 pounds of perennial ryegrass seed. Now we're exporting way less. And so these are some of the things that, okay, so how do we do that? Well, you look at your value, look at your net dollars after the year, after your whole rotation, to see where the strengths, where the weaknesses are.
Okay. We still have lots of questions, but I do have one more that I want to get to here quick. Has there been any published studies that correlate Brix levels in plants to different levels of insects feeding on the plant? So has there been any choice of food bioassay tests done?
Get a hold of Joel Williams. For the research part of it, I listened to Joel. I listened to Christine Jones, Chris Nichols, Yvonne Lawley. You can go through the list of the people out there. There's the research. They tell me, I believe it, and so am I gullible? Maybe. But when, on the farm, on other people's farms, especially when you start looking at the animal grazing behavior, and I did follow that up where I had my Brix meter and my garlic press, and the brome grass was knee high and the orchard grass was boot high, and you do a Brix on it and the Brix on the orchard grass is higher. You look at that blind taste test that my daughter did in grade 7 science. She picked the highest Brix every time. So go on to the wine world. They're always testing for Brix. So it's out there. I don't spend a lot of time looking at research because I don't need to prove it.
Okay. Well, we are now at 1:30. So Kevin, I really want to thank you for the presentation. Lots to think about. And I mean, just when we're talking about some of these other things and ways to get some of those, in a previous presentation, it was called the messy areas, where things aren't growing. These are definitely things that we could be thinking about to try and get those areas patched up and growing something again anyways. So thank you so much for your time.
Oh, not a problem. And I'll maybe go through the questions, and if something wasn't answered, I'll go through and try and answer them as I go. And otherwise, feel free to happening. We decided